Hello, and welcome to Foundations for Algebra, Unit 3B, Lesson 3. Today's objective is scholars will find the measure of angles using angle relationships within parallel lines and transversals. So, first thing we need to talk about is what are parallel lines and transversals? So, lines S and T are parallel. What does that mean? They are always the same distance apart, and they will never meet. They actually have the same slope, no matter which way they're going. So in this case, we have two lines that are horizontal with a zero slope. Okay. Next thing we're going to talk about is line M is the transversal. A transversal is just something that crosses a set of parallel lines. It's another line that just crosses a set of parallel lines. Not too hard. So, let's look at another angle. In this case, lines A and B are parallel, and line T is the transversal. Okay, so now let's talk about which angle pairs are vertical angles. You remember vertical angles are across from each other. So let's look at which angle pairs are vertical angles. So if I look at angle 1, the angle that's vertical to it is angle 3. If I look at angle 2, the angle that's vertical to it is angle 4. If I look at angle 5, the angle that's vertical to it is angle 7. And if I look at angle 6, the angle vertical to it is angle 8. So what do we know about vertical angles? You remember, vertical angles are always congruent. Congruent just means that they have the same measure. So if angle 1 is 75 degrees, so is angle 3. Okay, so they're congruent. So now let's talk about which angle pairs are adjacent linear angles. Okay, so I'm going to real quick erase all this stuff that I drew here. So let's talk about which angles are adjacent linear angles. Remember, adjacent linear angles just means that they are next to each other and they make a line. So I have angle 1 is adjacent linear with angle 4. They make a line. It is also adjacent linear with angle 2. So there's two different lines that can be made there. Angle 2 is adjacent linear with angle 1 and with angle 3. Angle 3 is adjacent linear with angle 2 and with angle 4. So you see, we have a whole bunch of adjacent linear also. What do we remember about adjacent linear lines, or adjacent linear angles? So adjacent linear angles are supplementary. That means they add up. Supplementary. That means they add to 180 degrees. So angles 1 and 4 would, angles 5 and 6 would, angles 7 and 8 would. Any angles that together make a line. So, the last thing we need to talk about is corresponding angles. When I say corresponding angles, I'm talking about angles that are in the same position on different parallel lines. So what do I mean? So I have these parallel lines S and T, and I've got my transversal M. So let's look at the angles that are made. You can see I have angle A, B, C, D, E, F, and G, and H. Okay? So, when I'm talking about corresponding angles, if I talk about angle A, look at where angle A is on here. If I picked up this set of angles and moved them down here on top of this set, which one would be on top of it? Or which one would it be on top of? So you can see that that's going to be angle C. They're both above the parallel line and to the left of the transversal. So they're both above the parallel line and to the left of the transversal. Okay? So if I'm looking at angle E, the corresponding angle would be angle G. It's above the parallel line and to the right of the transversal. If I look at angle B, the corresponding angle would be angle D. And if I look at angle F, the corresponding angle would be angle H. So here's the thing when we're talking about corresponding angles. Corresponding angles are, let's try writing with some of this, not a highlighter. They are congruent. So they're the same measure. So that means that angle A is congruent to angle C. So that means they have the same angle measurement. So one more thing with this. If I know that I have a set of parallel lines and set of parallel lines and transversal, there's actually only going to be two angle measurements. So let's look at this. Let's say I know that angle A, the measure of angle A, is 70 degrees. Okay, so if angle A is 70 degrees, that means corresponding angle C is also 70 degrees. But remember, we also have vertical angles. So that means angle F is also 70 degrees. And we have a vertical angle from angle C. Angle H is also 70 degrees. Then I can look at angles A and B are adjacent linear angles. They're next to each other and they make a line. That means, this should be angle A, sorry. The measure of angle B has to add up with the 70 to 180. So 180 minus 70 tells me the measure of angle B is going to be 110 degrees. Well, if angle B is 110 degrees, so is angle E because they're vertical angles. And angle D is corresponding to it, and angle G is a vertical angle from it. I know every single angle if I know what one angle is. Pretty cool. There's only two angle measurements. So, how can I use this? Well, let's look at this one. Find the measure of angle 5. That's what M of angle means. Measure of angle 5 if angle 1 is 35. So if angle 1 is 35, angle 1 and angle 5 are vertical angles. So that means angle 5 is going to be 35 degrees. I'm going to erase this over here because we're going to keep changing these values. So if angle 4, find angle 4 if angle 1 is 50. So if angle 1 is 50, angle 4 is down here. So angles 1 and 5 are... stop coloring things in here. Angles 1 and 5 are vertical angles. And angle 5 and angle 4 are corresponding angles. So that means that they're the same. So in that case, if angle 1 is 50, so then angle 4 is 50 degrees. Well, what about the next one? Let's find the measure of angle 7 if angle 2 is 137. So, here's angle 2, here's angle 7. They are corresponding angles, so angle 7 must be 137. And the last one asks us to find the measure of angle 7 if angle 6 is 150. So here's angle 6, here's angle 7. So angle 6 is corresponding with angle 3. And they're vertical, so they must be the same. So it's going to be, again, 150 degrees. Pretty easy to do. All we're doing is looking at them. Remember, there's only ever two angle measures. So, let's talk about some application. In this diagram, lines N and P, so you can see, I'm going to highlight our parallel lines. Lines N and P are parallel. These lines are parallel. And line Q is perpendicular. Line Q is this line right here. Perpendicular means they meet at a right angle. It is perpendicular. So we are going to justify two ways that we know the measure of angle 3. So here's angle 3 that we're trying to find. So first I see, the only measure I see here is a 42. So if that's 42, that means angle 1 is also 42 degrees. And angle 1 and angle 3 are corresponding angles. So then this is 42 degrees. We're using vertical angles and corresponding angles. Look at it and see if you see another way. Pause the video and check. Okay. Hopefully you found another way. Next one, justify 2 ways that you know the measure of angle 1. So, again, angle 1 is vertical to the 41, the one that says 42, so it is 42. That's it. Okay? Pause the video if you want to try and find another way. Okay, next one, let's identify the parallel lines. So we're going to do this. The parallel lines are these lines right here. Identify my transversal. My transversal is just this line right here. Problem 3 asks us how many angles are formed. Well, we can count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 angles are formed. Which of the angles are congruent? There's a whole bunch of pairs, so I'm actually going to erase all this stuff I did real quick. Maybe. Erase this real quick, sorry. And let's talk about this. So, if angle 5 and angle 2 are congruent, angle 2 and angle 4 are congruent, 4 and 7 are congruent. So all of those ones that is colored blue would be the same measure. Angle 1 is congruent with angle 6, and angle 3, and angle 8. They would all be the same measure. So there's only going to be 2 different measures. There are 2 sets. 2 sets of angles. There's one set that matches the yellow, one set that matches the blue. Okay, so go ahead and take some time to work on your classwork and your IXL, and I will see you in class. Bye-bye.